In this video, we'll be using PASCO Statics System to take a look at balanced torques, parallel forces. For this, we'll need the statics board. Attached to it is the balance beam assembly. Ooh, careful now. I just messed this up pretty good. Let's try that again. All right, there we go. So you need the statics board, balance beam, mass and hanger set, scale of some kind, and then these angle indicator assemblies. Now on these angle indicator assemblies, I have tied a string to the end of each of them. And the end of each string, I've tied a little knot, so it's just it looks like a little bulb at the end. It makes slipping it into the mass hangers much easier, I find, with minimal amount of work. You'll notice on here, on these indicators, right here is a white hash mark in this window. That'll indicate to you the distance that the center of the mass hanger is to the center of the balance beam. So to get this started, we need to measure the mass of the assembly with the mass hanger here. Let's go ahead and slip these in. And we'll use 50-gram masses. Right. And we'll go ahead and put both on the scale. So M1 is 65.5 grams. Make sure to put this in kilograms. Okay. That's M1. M2 with a 50-gram mass. 65.1. All right. So now we're going to hang these masses from the angle indicators and place them on the balance beam. I can get my string here. There we go. We're going to start off by putting these equidistant from one another and lightly tighten the thumb screw. All right. Oops. I did have it upside down there. There we go. Everyone. We're going to place these relatively equidistant. I'm just going to place them at the 100 millimeter mark. Tighten it. And do the same over here. To do the 100 millimeter mark. So right now, the torque should be balanced, which it looks like they are at these points. So let's just enter these distances in 0.1 and 0.1. And so the way the spreadsheet's set up is it'll calculate the torque of each one. So M1 has a torque of 0.06419 Newton meters, and the torque on the other, on M2, M2 I believe is this side now, yes, 0.06379. Mathematically not exact, but they are close enough to show equilibrium in the system. So let's do another case. We'll leave this mass right here in position where it needs to be, and we'll remove this one and we'll add another 50-gram mass. And then we'll try to balance this appropriately. We need to measure the mass. It's going to be 115.6. .56. And M2 is going to be the same at the same distance. So now we need to find the distance for M1. That'll make this system in equilibrium. Now we'll go ahead and replace the angle indicator back on the balance beam. And we'll adjust the position of M1 until the two are balanced. And we'll tell that they're balanced by looking at the bubble level inside here. And as we slowly adjust this, we'll find right about there is quite balanced. So now we read the measurement. Looks like we're at about 56 millimeters, halfway between 56 and 57. So we'll say 56.5. 5. So that gives us a torque of 0.064. Now let's compare that to the torque on the other, 0.0637. Very close, very well balanced. So from here, if you want, you can go on and extend this, and you can use the third angle indicator and add that to one of the other sides and balance the torques using 3 torques instead of just 2. That's all I got for you. That is the basics of using the static system in order to measure and record balanced torques.